Okay, in this video, we are going to look at the second part of scientific notation. So it's going to be scientific notation part 2. I got to get my screen up here, share with you. So that's where we left off. So that's where we should have ended on the last video. And so now we're going to come up here to multiplying and dividing numbers expressed in scientific notation. So numbers that are written in scientific notation can be multiplied and divided by using the properties of numbers and the rules of exponents. So here's where we are really going to use those exponent rules that we talked about in one of our other lessons. And it says to multiply numbers together that are already expressed in scientific notation. What I'm going to have you do is group the mantises together. So that's what we're going to do. We're going to group the mantises together and we're going to multiply them. So multiply the mantises. Next, you're going to multiply the powers of 10 by adding the exponents. And then finally, you're going to convert the new product into scientific notation. So what you're doing is you're assessing your final answer at the end to find out, is it in proper scientific notation? That's what you're checking for in that last step. So you're checking to see if the mantises that you multiplied together in step 1, is that mantissa in between 1 and 10? And if not, we've got to do a little bit of work with that answer. So on quizzes and exams, I am specifically looking for this process. And I know you can do it a lot of different ways. I know your calculators can just do this for you, but I am looking for you to understand the process behind it. So please make sure that you're following the steps that we're doing here in class, because otherwise you're going to lose, a decent portion of points on this skill. So the first example that we're going to try out here is 1.02 times 10 to the negative 4th. And we are going to take 3.2 times 10 to the 6th. And so at this point, I'm hoping you're noticing that the only operation that is occurring between all of those numbers is multiplication, because we've got multiplication here, and then we've got multiplication here, and we've got multiplication here. I've had some students say that this looks like the distributive property. We're going to use FOIL, and so we're going to do first terms, outside terms, inside terms, last terms. No, we don't do that. We only would do that if instead here, these were addition or subtraction. But we don't have that. So all we have is multiplication. So we can use what's called the commutative property and shuffle our terms around. So that way we can multiply our mantises together. So we're going to do, and this again is a process I look for on your papers when we're doing quizzes and exams. So we're going to do 1.02 times 3.2. We're moving these mantises next to each other. I am then going to put an X sign for multiplication, and I'm going to say 10 to the negative 4th times 10 to the 6th. So I'm taking my powers of 10, and I'm grouping those guys together. So then I want you to take in your calculator, you're going to do 1.02 times 3.2, and what you should be getting is 3.264 for that. And then for our powers of 10, we're going to use our powers of our rules of exponents, and we have the same base here. So what do we get to do with those exponents? We're going to add them. So we have times 10, negative 4 plus 6 is going to be 10 squared for that one. So then you look at your number at the final answer and you say, okay, is this number in proper scientific notation? And the answer to that is yes, because this mantissa is in between 1 and 10. So it's perfect. We can actually just circle or box that answer up. That one is done. So let's look at another example. So our second one is that we have 5 times 10 to the 11th. We're going to put that in parentheses. That's our first quantity. And we're going to multiply that by another quantity of 2.9 times 10 to the negative 3rd power. And so again, group the mantisses together, group the powers of 10, and you guys should pause the video, try this one on your own and see if you get it right. So I'm gonna go ahead and group my mantisses together. I'm gonna put times 10 to the 11th, times 10 to the negative 3rd. 5 times 2.9, you should be getting 14.5 times 10, and then here you're taking 11 minus 3, and then that should be giving you 8 here. And then you're looking at your final answer and you're saying, is that number in proper scientific notation? And the answer is no. So this right here is not in proper scientific notation. And so what we need to do here is you need to ask yourself, okay, well, what do I need to do to that? Do I need to multiply it by 10 or do I need to divide it by 10 in order to get it in between 1 and 10? And I'm hoping you're saying we need to divide it by 10. So if we divide it by 10, that's essentially like going like this, right? So we're dividing it by 10, but if I divide the left side of that same number by 10, what do I need to do to the right side? And I'm hoping you're not saying divide by 10, because that's what you might be asked, like, hey, I divide by 10 on this side of the equation. What do I do to the other side of the equation? And you would say divide by 10. We don't have an equation here. We have the same number. So if I am manipulating my same number and I'm dividing one portion of it by 10, then I have to multiply the other portion by that same amount so that my number stays the same. And so in this case, we are going to multiply by 10 right here. So then what ends up happening is that if we're dividing by 10 on this left-hand side, this decimal is going to move 1 over, and you're going to get 1.45 times 10 to the 9th. And then you look at that as your final answer and say, does that look right now? And the answer to that is yes. And what you can always do is go check this. Go check it in your calculator and make sure that you did do it right. Your calculator, at least the calculator, if you borrowed one from me, that looks like this, there is an EE button right above the number 7. And that EE button, we would go, like if I wanted to check this to see if I did this right, so this is my check, and me using my calculator, I would do 5 EE, and what that EE does is it does the times 10 part of it. And so you would do 5 EE 11, and then you would do times 2.9 EE negative 3. And so you plug that in. And then you get your answer. And then your answer that you get, I honestly don't know if it comes out in scientific notation or not. But then what you can do, I'm going to guess not. I'm going to guess it's going to come out into decimal notation. I don't know. If it comes out in scientific notation, you can just check it right here and see if that's right. If it doesn't, I actually think it probably, hang on, let me just check it real fast. 5 EE 11 times 2.9 EE 3 negative, and it gives you the big number in decimal notation. So then you can take that number and you can compare it to this one if you take this answer over here and you convert it into decimal notation, and then compare and see if they're correct. So that's one way to check your answer. All right, let's look at number 3. All right, so number 3 gives you 3.6, oops, let me get rid of that, 3.6 times 10 to the negative 12th, and then we are going to multiply that by 6 times 10 to the 9th, and again, I want you to take your mantisses, we're going to multiply those together, 3.6 times 6, and then we're going to do times 10 to the negative 12th, times 10 to the 9th. And then 3.6 times 6, again, put that in your calculator. You should be getting 21.6 for that. Then take your negative 12 plus a 9, and that's going to give you negative 3. And then you look, is this number in proper scientific notation? No. What do we need to do? we needed to divide this one by 10. So that way it'll bump this over to the left, right? And if we divide this by 10, we've got to multiply this one by 10. So then we're going to get 2.16 times 10 to the negative second power. And that should be your final answer on that one. So the next one that I would like for you guys to try on your own, and then I'm going to see how your answers compare. We're going to have, not 3, sorry, looking at a wrong problem. We're going to have 5.02 times 10 to the 0. And then we're going to have times 7.2 times 10 to the 6th. So what I would like for you to do is to try that one and see what you come up with. Your final answer when you were done with it should be 3.6144 times 10 to the 7th, just so you can check your work. But I want to see the process here, like what we've been doing so far in class. All right. So now we're going to do the next part of this. And to divide numbers that are already expressed in scientific notation, guess what? We're going to divide the mantises just like you multiplied them. Divide the mantises. Next, you're going to divide the powers of 10 by subtracting the exponents. Then we're going to convert the new quotient. Again, remember quotient, that's just the answer to a division problem, into scientific notation. So there are the blanks for your notes. Now we're going to do some examples doing that. And again, same thing. I'm looking for this process also on quizzes and exams. All right, so we've got the first one and it says 2 times 10 to the negative 4th. We're going to divide that by 8 times 10 squared. Again, what I would like for you to do is to group up your mantises. So we're going to go like this, times 10 to the negative 4th, all over 10 squared. And so at this point, we're going to take 2 divided by 8. You're not going to leave it in a fraction form this time. So 2 over 8 is going to be 1/4 or 0.25. And then we're going to have times 10. And then to bring that up, we're going to subtract off that 2, right? Because that's the same as us doing times 10 to the negative second. And so if we're combining those, it's going to be negative 4 plus a negative 2. And so then we're going to get 10 to the negative 6th. And then we look at our answer. Are we done? No, because 0.25 is less than 1. So we've got to convert that. So in order to move it one way to the right, like that, that means we're multiplying this side by 10, right? To move it to the right, which means what do we have to do on this side? We've got to divide it by 10. So we're going to divide it by 10. So now we've got 2.5 times, and then again, if we're bringing that up, we're subtracting that 1 off, that exponent. Or again, you can think of it as like multiplying by 10 to the negative 1. And then we've got times 10 to the negative 7. And then you're looking at your final answer and you're saying, does that one look like it's in proper scientific notation? And the answer to that is yes. So now let's try another example. So number 2, we've got 1.2 times 10 to the 4th, and that's going to be all over 3 times 10 to the negative 2nd. So again, you're going to group your mantises together and then group your powers of 10. So if I'm you, pause the video, see if you can do this one on your own, and then check your answer at the end to make sure you got it right. So we're going to group the mantises. We're going to put 1.2 over 3 times 10 to the 4th all over 10 to the negative 2nd power. You can put that in your calculator if you want to, or you can say, well, I know that 12 divided by 3 is going to be 4, so 1.2 divided by 3 is going to be 0.4. And then we're going to have times 10 to the 4th, and we're subtracting off whatever that exponent was, which is going to be minus the negative 2. Again, that other form of looking at it is you saying, bring that 10 up to the numerator. It's going to be 10, and then we flip the sign on it because we're bringing it up to the numerator. It's going to be positive. So then we've got 0.4 times 10 to the 6th on that one. And we still have to do some work here. So this one, we need to move the decimal point one place that way, because again, we need our mantissa in between 1 and 10. So that means we're multiplying this part by 10, which means we need to divide this part by 10. And so here we've got 4 times, and again, you're going to subtract off that 1, or you can write times 10 to the negative first power. And then we're going to have times 10 to the 5th for that one. And then that's going to be your final answer. And then I've got one more that's kind of an involved problem. This one shows up on quizzes and exams, the type of problem, because it puts all the pieces together. So you have to, on this type of problem, I want you just to follow the steps on this problem. Very important problem to make sure you're understanding it. Okay, so we have got 2,000 times 0. Let me count my zeros. 1, 2, 3, 4. 1, 2, 3, 4, 2, 1. All over 700. And of course, like if the directions didn't state what I'm going to tell you that they state, of course you could just in your calculator do 2,000 times whatever that decimal number is and then divide it by 700. And then boom, you've got your answer. But the directions on this problem will state, convert those numbers first into scientific notation, and then convert them, like you're going to multiply those numbers that are in scientific notation and divide them using the processes that we have used in class. And so you just need to make sure that you're following these steps, because otherwise you're going to miss a whole bunch of points on this problem. So again, the directions, if you want to jot them down, the directions for this problem will say first, convert those numbers into scientific notation, and then follow the process we've used in class or in these lecture videos to multiply and divide the numbers in scientific notation. So you're using scientific notation throughout. So what that means we need to do first is convert them into scientific notation. So right here, a decimal is here. So it's going to be 1, 2, 3. So we've got 2 times 10 to the 3rd for that first number. And then here we're going to have 1, 2, 3, 4, 5. So it's going to be 2.1 times 10 to the negative 5th. And then that's going to be all over 1, 2, 7 times 10 squared for that one. So 7 times 10 squared. Now what I would like for you to do is group all your mantisses together, group all your powers of 10 together. So here we're going to have 2 times 2.1 all over 7. So I'm grouping my mantisses together. And then I'm going to put my powers of 10 together. So it's going to be 10 to the 3rd times 10 to the negative 5th all over 10 squared. Now in your calculator, you can do 7 times 2.1 and then, or not 7, 2 times 2.1 and then divide that by 7 and you should be getting 0.6. I'm going to move up here. So you should be getting 0.6 from that. And then for my powers of 10, I'm going to say times 10 to the 3rd minus 5 minus 2. Because again, I'm bringing this guy up, so it's going to be 10 to the negative 2nd. So then I'm just adding and subtracting my powers of 10 up here. So then I've got 0.6 times 10. 3 minus 5 is going to give you negative 2. Negative 2 minus 2 is going to give us negative 4. And then, again, we look at this. This is not greater than 1, so we need to multiply this by 10, which means we need to divide this one by 10. So we're going to have 6, because we're moving that over by 1. So we're going to have 6 times, and then again, remember that's a 1. So we're going to bring that up to the numerator. And then negative 4 minus 1 is going to be times 10 to the negative 5th. And again, I am very much wanting you to make sure you're following those steps on your notes, because again, these show up on assessments, and I'm looking for all of those steps to be on your paper because you're communicating to me on paper that you know not only how to convert decimal form into scientific notation, but you also know how to convert the forms, like you're knowing how to multiply numbers that are in scientific notation and then also divide them. So that's the method behind the madness. All right, so we're going to look at these application problems. I'm at least going to get you started on them. So here it says, in February 2010, the population of the US was approximately 308.4 million. Express this population in scientific notation. So let's first write that out. 308.4 million, so that's going to be 308,400,000 for that. So now take that number and move it into scientific notations. We're going to go 1, 2, 3, 4, 5, 6, 7, 8. So then we've got 3.084 times 10 to the 8th. Did I write that right? Okay. And then my label. So I've got that many people. And then it says in February, so we're going to use this. This is one of those problems that's just going to be building on each step. So then it says in February 2010, the U.S. House of Representatives voted to allow the government to go $1.9 trillion deeper into debt, giving a total debt of about $13.5 trillion. Calculate how much total debt this is for every U.S. resident using the February 2010 population, which is what we did in number 1. After you get your calculation in scientific notation, then express the amount in standard notation to the nearest dollar. So this one is a pretty involved problem, and we're just gonna go after it. So here we go. One of the things, and I just think in general, so it's asking you how much money per person. Like if everybody's like, let's all chip in and we're gonna get our country out of debt, and we're gonna say everybody owes the same amount of money no matter what. So we're gonna take the total amount of debt and we're gonna divide it by the total amount of people. And so I want you to think about that process. So we're gonna take total debt and we're gonna divide it by total number of people. All right. So it says our total debt is about $13.5 trillion. So let's first write that number out into standard notation. So if we've got 13.5 trillion, that's going to be 13,500 billion. 1, 2, 3, 1, 2, 3, 1, 2, 3. So billions. Okay. So this is $13.5 trillion, and now we need to convert that back into scientific notation. So we've got, 3, 6, 9, 12, 13. So I'm just going to write that down. So it's going to be 13 spaces or 13 places there. So our total debt is going to be 13, or not 13. No longer 13.5, it's going to be 1.35 times 10 to the 13th, there's my 13, divided by the total number of people, which is what we did in the problem just above, which is 3.084 times 10 to the 8th. And now, looking at what it says calculate how much total debt this is for every U.S. resident using the February 2010 population. That's what we're getting ready to do. So first, we're going to get our answer in scientific notation. Then we're going to express it in standard notation to the nearest dollar. So here, you're going to group your mantisses again together. You're going to do 1.35 divided by 3.084 times 10 to the 13th all over 10 to the 8th. So we're going to divide that. And then when you divide these two, you're going to get a long kind of nasty decimal. So here I'm going to put some squiggles because the decimal keeps going. And we're going to get 0.437743191, and it might keep going. I don't remember. And the reason why I'm taking it out that far is because I know on this side over here, we're going to have 10 to the 5th. And so thinking about this number on my mantissa, if I move that decimal place 5 places to the right, 1, 2, 3, 4, 5. Up here it says, then express my final amount in standard notation. And we're going to round it to the nearest dollar. So we're rounding it to the nearest whole dollar. And so this is how much money per person that each of us would need to pay to get our country out of debt back in 2010. Well, let's put it into a form that it might make more sense to us. And so we're going to say 1, 2, 3, 4, 5. We're going to move it over there. So then it's going to be, we've got 43774.3191 ... And then rounding that to the nearest dollar. So here we've got a 3, which means rounding it to the nearest dollar, each of us would get to chip in $43,774 per person. And that would leave it, so I'm just going to point this out. What that would do though is that would make it so the government would need to chip in that extra little bit that the rest of us wouldn't cover, because there's that 0.3 and it said to round to the nearest dollar. All right, so there's that one. So what I want you guys to do on this one, it says in 2009, the national debt of the US government was about 11.9 trillion. Okay, so we have 11.9 trillion. And then using 307.0 million as the population for that year, about how much was this per American? So next, write this amount in standard notation to the nearest dollar. So in number 3, what you're doing is that you're doing all of these steps. So the steps that we did in 1 and 2, you're doing those steps in number 3, because still you're looking again for how much money, so how much money is it per person? And the population right here is this 307 million as a population for that year. So what you're gonna need to do is, again, you're taking your debt, 11.9 trillion, and you're dividing it by your 307.0 million, because it's how much money per person. So what you're gonna need to do first is put these in your standard notation, just like we did up above, then convert them into scientific notation, just like we did right here. So then you're gonna write them in scientific notation, then you're gonna group your mantissas, then you're gonna group your powers of 10, make sure you take your decimal out a good ways, then you're gonna convert that number and put it back into standard notation, so that way we know how much money per person to the nearest dollar. So I want you guys to try that one. And then for number 4, it's the same type thing. So you're trying this one too. So it gives you a different year or a different time period, and it gives you the debt, and it gives you the population, and you're supposed to do the same thing and express it to the nearest dollar. So I want you guys to try out both of those on your own and then see how you do on those. And if you need some help, again, contact me. I'm happy to help you with those. Thanks for tuning in.